I am Vojtech Bardiovsky, and thanks to the summer of HPC I spent my summer at the Barcelona Supercomputing Center. The BSc maintains the most beautiful supercomputer in the world and is one of the few CUDA centers of excellence. The managing director of the Center of Excellence is Mr. Nacho Navarro, who was also my mentor during the program. During the first week we received a training in advanced concepts of CUDA at the inspiring PUMP summer school. The knowledge received at the summer school and at the BSc led to a much better understanding of the project's aims and implementation. The project is a cooperation between the BSc and Herta Security, the world leader in facial recognition development. The project's aim is to implement and evaluate the newest techniques in face recognition and parallelize them on the GPU using CUDA. Face recognition has many applications in surveillance, security and marketing. Parallelization is necessary here because most applications require real-time processing and many faces are processed in parallel. So, how does face recognition work? Let's see a simple example using the local binary pattern descriptors. We will go through a universal pipeline from the start to the end. Let's borrow a portrait of Madame Recamier from Louvre and hope they don't mind. After converting to grayscale, it loses some of the beauty, but we are not here to enjoy the art. After running a face detection algorithm, which is a different chapter, we find the location of the only face in the image. Here we use the OpenCV library for detection. Now we have the face, but generally this can come in different illumination conditions, and to cancel out this effect, the photometric normalization has to be performed. There are many algorithms that do this, like Retinex, difference of gradients, or Gaussian smoothing, but let's just stay with the difference of gradients. The image is now prepared and we can extract the local binary pattern descriptors. It is called local because for every pixel we look on its close neighbors. Let's select one pixel and extract the binary pattern of its neighbors. This is the closest area of the pixel zoomed in. Now compare the intensity of the center pixel with the others. Only two values are possible, larger intensity or smaller intensity, and this is why it is called binary. We can interpret the pattern as a binary number, in this case it is number 112. This way every pixel can be described by a number between 0 and 255. Let's take these numbers from every pixel and build a histogram. Just out of interest, the column for our previous pattern is here.
So, how can a histogram help us estimate the gender of a person? We apply some of the techniques of the machine learning. A very simple one is called the nearest neighbor algorithm. To estimate a label on an object, in this case male or female, it finds the closest neighbor in a space of training samples. Here the space is 256 dimensional, one dimension for every histogram column. This algorithm is very simple, but still it requires too much processing power. The reason is that for one image we have to scan every part of it using a sliding window with different sizes. Parallelization can speed up this process dramatically. After extracting the faces, we can work on each of them independently. What is more important is that the whole processing pipeline for processing of one face can be parallelized. For estimation we use a more complex technique than just simple LBP called discriminative features. This has been tested on 3 public face databases and the estimated attributes were gender, ethnicity and age. The parallelization of feature extraction on CUDA gives more than 20 times speedup if you don't consider the memory transfer and 3 times speedup if you do. The OpenCV library also runs on CUDA. The estimation accuracy is generally highest for the gender and ethnicity, which in all training sets reaches 92%. For the age estimation, the accuracy means the ratio of samples that were predicted correctly in the range of ± 5 years. The accuracy reaches at most 73% using this approach. I would like to thank my mentor Mr. Nacho Navarro and my supervisor at Herta, Mr. Carlos Fernandez. Also, I would like to thank the summer of HPC for a great program.